guys, thanks for joining us. I'm Steve Zaragoza.
And I'm Joe Beretta.
In our ongoing struggle as human beings to live longer, Dr. Nathaniel Schwezek of the University of Nottingham is leading a new study that says going into space could make you live longer. Which sounds awesome if we could, go into space without like working for NASA or something?
It's true that when astronauts spend a long time up in the great unknown, the effects of zero gravity can weaken the body and atrophy the muscles. Only 4 people have logged even an entire year continuously in space. This dude, the record holder for most time spent in space, spent 2.2 years in space over the course of 6 space flights. That's just enough time to see how easily the muscles can atrophy and bones can deteriorate after spending a long time in total weightlessness.
But this study shows that worms taken into space and exposed to zero gravity causes certain genes to be expressed at lower levels than they would on Earth, and toxic proteins that normally accumulate in the muscles are largely suppressed. Well, apparently the C. elegans, which is the worm species frequently used in space travel, suffers muscle atrophy surprisingly similar to humans. And when Schwezek replicated those changes in gene expression in the worms in the lab, they started living longer.
That's all cool and all, but guess what? The team of scientists working on all this wormy, sciencey stuff aren't totally sure what's actually causing this longevity effect. But Dr. Schwezek has some ideas, and there's a good chance humans could enjoy the same boost in life, as he explained in a recent statement. We identified 7 genes which were downregulated in space and whose inactivation extended lifespan under laboratory conditions. We are not entirely certain, but it would appear these genes are involved in how the worm senses the environment and signals changes in metabolism in order to adapt to the environment. For example, one of the genes we have identified encodes insulin, which, because of diabetes, is well known to be associated with metabolic control. In worms, flies, and mice, insulin is also associated with modulation of lifespan.
Nice work, Joe.
Thank you.
Okay, so what does this mean for future Ripleys and Han Solos? Schwezek speculates most of us know that muscle tends to shrink in space. These latest results suggest that this is almost certainly an adaptive response rather than a pathological one. Counterintuitively, muscle in space may age better than on Earth. It may also be that spaceflight slows the process of aging.
Yeah, but spaceflight is also known to cause some serious problems with the immune system and cardiovascular system, which is kind of a big deal as far as the body's, biological workings go.
And don't even get me started about traveling outside the vicinity of Earth. There's cosmic radiation and decreased production of red blood cells, balance disorders, loss of body mass, nasal congestions, sleep disturbance, and excessive flatulence.
And don't forget the crazy bug things from Starship Troopers.
Yeah, but mostly farty spacesuits.
That kill you. Do you think we're heading in the right direction focusing on the exploration and study of space travel, or do you think we need to continue focusing on matters here on Earth? Let us know in that comment box down below.
And why don't you hit like and subscribe if you haven't already? It really helps us out. And click this annotation to go to SourceFed.com and see every video we've ever done from space and about space and the 5 stories of the day. I'm Steve Zaragoza.
I'm Joe Beretta. We're in space. We really are technically all in space.
We're flooded. We're on Spaceship Earth.